Hello and welcome to Grace Tutorial. In this video lecture, we will be discussing about the part 10 of Aldehydes, Ketones and Carboxylic Acids. Here, we are going to discuss the entire things about the methods of preparation of carboxylic acid. So if we consider about the methods of preparation of carboxylic acid, the first method we have from alcohol. So now we have to try to prepare the carboxylic acid from alcohol. But how? You see, we have three types of alcohol. One is the primary alcohol, another secondary alcohol, and third one tertiary alcohol. What is the formula for primary alcohol? RCH2OH. Similarly, the formula for secondary alcohol RRCHOH, where both alkyl groups are there. But in tertiary alcohol, we have three alkyl groups. So here in this way we have three different types of alcohol: primary alcohol, secondary alcohol and tertiary alcohol. Now we need to prepare the carboxylic acid, but from which alcohol? Suppose we will take the primary alcohol. What is the formula for primary alcohol? RCH2OH. When the primary alcohol gets oxidized, we know that because during the preparation of aldehydes as well as the ketones that we used the alcohol. That means when the primary alcohol gets oxidized in the presence of potassium dichromate, so K2Cr2O7, this is potassium dichromate, or KMNO4, potassium permanganate. When this primary alcohol gets oxidized, then this H2 will be broken and finally it gives RCHO and water is removed here. That means the aldehyde is produced. So RCHO means aldehyde. Yeah. So if again the oxidation takes place to that aldehyde, that means if aldehyde is again oxidized, then we have RCOOH. This is acid. Acid is obtained. That means here the formation of acid takes place by the two steps. Step number one, the primary alcohol gets oxidized in the presence of the oxidizing agents like the potassium dichromate or the potassium permanganate, and it gives aldehyde with the liberation of the water molecule. And if that aldehyde again gets oxidized in the presence of same, potassium dichromate or KMNO4, then we get acid. Let me give you the specific example for this. Suppose here we'll take methyl group, CH3, CH2OH. This is ethyl alcohol. When this ethyl alcohol gets oxidized in the presence of K2Cr2O7, that is potassium dichromate, or KMNO4, potassium permanganate, then CH3, CHO. So here it's nothing but I have just placed the methyl group here in the place of this R. So what is the name of this compound? Acetaldehyde. And if that acetaldehyde is further oxidized, then we get CH3COOH. This is acetic acid. So this is the first method where the acid is prepared from alcohol. let me repeat it once more so that you can understand it very clearly. What are we doing here? We are learning the different methods of the preparation of carboxylic acid. So the first method that we have from alcohol. When the primary alcohol gets oxidized, that means oxidation of alcohol takes place. So when primary alcohol gets oxidized in the presence of the potassium dichromate or potassium, potassium permanganate, then aldehyde results. If that aldehyde is further oxidized, then acid results. So this is the specific example. I have just placed the methyl group in the place of this R. That's it. So when ethyl alcohol gets oxidized, acetaldehyde is obtained, and further oxidation of acetaldehyde gives the acetic acid. This is the first method of the preparation of carboxylic acid. Now we will move on to the second method of the preparation of this carboxylic acid, and the name of that method is from aldehyde. From aldehyde. If you look at aldehyde, we have aldehyde RCHO. When this aldehyde gets oxidized in the presence of potassium dichromate or potassium permanganate, then we get acid. This is aldehyde. If you will give the specific example for this, CH3CHO, this is acetaldehyde. When this acetaldehyde gets oxidized in the presence of the same, then we get CH3COOH. This is acetic acid. So this is the second method of the preparation of the acid. Actually, if you know the first method, that is from alcohol, you can also come to know about the second method. Why? Because the first method follows the two steps, and the second step, this is what we have done. So in the next method of the preparation of carboxylic acid, the second step of this first method is to be followed. That means aldehyde gets oxidized in the presence of potassium permanganate or the potassium dichromate, then we get acid. That means we can prepare the acid from the carboxylic, we can prepare the acid from the alcohol as well as from aldehyde. So this is the first method from alcohol, and the second method wherein the acid has been produced, that is from aldehyde. Now we will move on to the third method of the preparation of carboxylic acid. Well, if we look at the third method of the preparation, that is by the hydrolysis of alkyl cyanide. That is RCN. So suppose I have alkyl cyanide. When this alkyl cyanide gets hydrolyzed, that means addition of water in the presence of dilute HCl and aqueous solution of sodium hydroxide, then RCONH2. So what is the name of this compound? Amide. First of all, the hydrolysis of alkyl cyanide gives amide. So this is alkyl cyanide. And in the further, if it reacts with, if it again hydrolysis, if again the amide gets hydrolyzed, then we get RCOOH, that is acid. That means the formation of acid here follows the two steps. Number one, hydrolysis of alkyl cyanide. So hydrolysis of alkyl cyanide in the presence of dilute HCl or aqueous solution of sodium hydroxide, it gives amide, but amide on further hydrolysis, it gives the acid. Now let us take the specific example. CH3C, this is methyl cyanide. When this methyl cyanide gets hydrolyzed in the presence of the dilute HCl, hydrochloric acid, or aqueous solution of the potassium hydroxide, then CH3CO and H2. CH3CO and H2. So what is the name of this compound? The name of this compound is acetamide. When this acetamide is further hydrolyzed, then we get acetic acid. Yeah. That means RCOO RCOOH, and we have ammonia as well. Ammonia results similarly here, ammonia. So this is acetic acid. So methyl cyanide on hydrolysis in the presence of dilute HCl or NaOH, first of all, on addition it gives acetamide, and further the acetamide gets hydrolyzed to form the acetic acid. This is all about the third method, that is by the hydrolysis of alkyl cyanide. Now we will move on to the fourth one, that is from ester. What is the formula for ester? RCOOR. So I have taken ester. When this ester gets hydrolyzed, it gives hydrolysis. That means if water gets dissociation, then we'll get H plus and OH minus. RCOOH plus ROH. So when ester gets hydrolyzed, hydrolysis, if the water molecule gets dissociation, then we get H plus and OH minus. So this RCOO minus, anyhow this RCOO minus reacts with H plus and finally gives RCOOH. This is acid. And this is alcohol. If we will take the specific example, here we have CH3, COO, let us take C2H5 plus water. So what CH3COO C2H5, what is the name of this compound? Ethyl acetate. This is ethyl and CH3COO minus acetate. So the name of this compound is ethyl acetate. Ethyl acetate on hydrolysis. Why I am giving this equilibrium sign? Because this reaction is reversible in nature. CH3COOH, acetic acid is obtained. Then C2H5OH. This is ethyl alcohol. When ethyl acetate on hydrolysis, it gives acetic acid along with ethyl alcohol. And if acetic acid and ethyl alcohol reacts together, then ester is formed. That's why this this reversible symbol has been given. That means from ester we can prepare the acid as well. So this is the fourth method of the preparation of carboxylic acid. And now we will discuss the last method of the preparation of carboxylic acid, that is from Grignard's reagent. Now the question is how the acid is prepared from Grignard's reagent. Fifth method, from Grignard's reagent. So what is the formula for Grignard's reagent? RMgX. When the Grignard's reagent is treated with carbon dioxide, that is So the structure of carbon dioxide, Grignard's reagent. So the carbon dioxide is boiled through the Grignard's reagent. First of all, it gives the addition product. This is addition product. And on further hydrolysis, it gives RCOOH acid plus MgOHX, magnesium hydroxy halide. So acid is obtained in this way. That means the Grignard's reagent reacts with carbon dioxide. That means the carbon dioxide is boiled through the solution of the Grignard's reagent and it gives the addition product, and on further hydrolysis it gives the acid. Let me give you the specific example. Or if you will take CH3 MgBr, methyl magnesium bromide. Methyl magnesium bromide. When this methyl magnesium bromide reacts with carbon dioxide, that is CO2, first of all it gives addition product OMgBr. This is addition product, and on further hydrolysis it gives CH3 COOH, acetic acid. And MgOHBr, magnesium hydroxy bromide. Let me write the name for you. Magnesium hydroxy bromide. Yeah. So this is what, in this way that we have prepared the acetic acid. This is the fifth method, that is from Grignard's reagent. So if the question comes that how can we prepare the acid from the Grignard's reagent, and this is also called the carboxylation of Grignard's reagent. Let me write here. Carboxylation, because the carbon dioxide gas. Carboxylation of Grignard's reagent. The carbon dioxide gas is reacted with Grignard's reagent. That's why this is carboxylation of Grignard's reagent. And by the carboxylation of Grignard's reagent, the addition product first of all results. On further hydrolysis, it forms the acid. In this way, that we can form the acid from the different methods, starting from alcohol, aldehyde, hydrolysis of alkyl cyanide, and hydrolysis of ester, and finally from Grignard's reagent, that is the carboxylation of Grignard's reagent. So these are the various methods of the preparation of carboxylic acids. So if the question comes that explain any two methods of the preparation of carboxylic acids, or what are the different methods of the preparation of carboxylic acid, or sometimes the question may come in the examination that what happens when the Grignard's reagent reacts with carbon dioxide gas, or sometimes it is asked in the examination then what happens when ester gets hydrolyzed. So that you need to remember these different steps, these various steps, so that it will be very much helpful for your examination point. Well, this is all about the methods of preparation of a carboxylic acid. And in the next one, that we will discuss about the physical properties of carboxylic acid.